Here we go. We are ready to start Chapter 9. And when we start Chapter 9, the first thing that we are going to do is review the Pythagorean theorem. And the reason we are going to do that is because Chapter 9 is all about right triangle trig. And if you remember the Pythagorean theorem, a squared plus b squared equals c squared, which we're going to talk about a little bit more here, that it only is possible if you have a right triangle. So we're going to review the Pythagorean theorem, and we'll use it a lot during this chapter. So in the diagram that I have here, we will know that it's a right triangle because I'm going to tell you it's a right triangle. And we are going to label the legs and the hypotenuse. Remember, the legs are always the sides that make the right angle, and they are A and B. And A and B can be interchangeable. So I could have B here and A here, or vice versa. And then C is the hypotenuse. And C is always the longest side. Oops. And A and B are the legs, and they are shorter in length than the hypotenuse because the hypotenuse is the longest. So we always, whatever the longest side is always going to be side C. And the Pythagorean theorem, you probably have heard before, is a squared plus b squared equals c squared. We are doing right triangle trig this semester. We are actually going to flip it just a little bit, and we are going to say c squared equals a squared plus b squared. That's just the symmetric property of equality. So, and you'll see here in a little bit when we do some more notes why we put the c squared on the left and not the right. So we'll move on from there. So we're just going to use the Pythagorean theorem. We're going to look at some examples. We're going to use that formula, plug it in, use our calculator, and we are going to calculate a side length. Okay, so as we look at a problem here, I have side lengths of 5, 12, and an unknown. First thing I want to identify is what's A and what's B and what's C, because that's going to impact where they go in my formula. So I have this side and this side make my right triangle, so that's going to be my A and my B. And then X over here is my hypotenuse, so that represents my C. So I am going to use my Pythagorean theorem, c squared, I'm going to write that one more time, equals a squared plus b squared. Okay, well C we said was X, so we're going to say x squared equals 5 squared plus 12 squared. And then a little bit of this you can actually do in your calculator. If you add 5 squared plus 12 squared, you get 169. And then our last important step that we can't forget is that we don't want x squared, we want x. So to undo x squared, we take the square root of both sides. And the square root of 169 is exactly 13. It's a perfect square, which also means that 5, 12, and 13, if we had those as side lengths, that those side lengths would make a Pythagorean triple. All that a Pythagorean triple means is that none of the sides that you have are decimals or radicals or anything like that. They're all whole numbers. So let's take a look at this next one over here. We have side length 7, x, and 14. And the two sides that make up our right angle, right here and right here, those are going to be our A and our B. And then again, across from the right angle, or our longest side, is going to be C. Okay, so again, we're going to use c squared equals a squared plus b squared. All right, so if we substitute those in, we're going to have 14 squared equals 7 squared plus x squared. 14 squared is 196. 7 squared is 49. Again, I got to get that x squared all by itself, so I'm going to subtract 49 from both sides, and I get 147 equals x squared. And in that last step, we always want to make sure we take the square root, and x is going to be the square root of 147. And if we are going to round that, that would be approximately 12.12. All right, so then there's just a couple more examples down here. We'll just look real quick. We'll do them a little bit faster this time. So we have, here's my hypotenuse. It's across from the right angle. So that's going to represent C, A, and B are my legs. So I'm going to have 8 squared equals x squared plus 4 squared. Again, when your hypotenuse is a number and not your missing variable, it takes a little bit more work. So you'd have 64 equals x squared plus 16. If I subtract 16 from both sides, I get 48. And then again, my last step here is I need to make sure that I take the square root of both sides. So I get the square root of 48, which is approximately 6.93. Okay, and then our last one here. I've got my two sides that make my right angle. There's my A and my B. And then my hypotenuse, longest side across from my right angle is C. So I'm going to have x squared equals 7 squared plus 6 squared. And when you calculate that out, x squared equals 85. And if you take the square root of both sides, you get that x, well, is the square root of 85, or 9.22. And as with anything, it's always a good idea when you get your answer just to go back and double check that your answer makes sense. So like if I get 9.22, if I put it back in here in my picture, it is the longest side, which it should be because it's the hypotenuse. Okay, the last thing is if it's not a right triangle, which means the Pythagorean theorem will work, okay, then there is a way to know if it is an acute triangle or an obtuse triangle. Okay, so this is why I said to put c squared on the left. So how do I know if it's right, acute, or obtuse? Well, the Pythagorean theorem says that if it is equal, if c squared equals a squared plus b squared, it's a right triangle. Well, if when you square that longest side and it is less than when you add those other two sides, it's going to be acute. I like to have the c squared on the left side here because to me, less than symbol, that less than symbol, I always think of an acute triangle as having less than, or excuse me, acute angle of having less than 90 degrees. So that less than and less than kind of go together to help you to remember. And then again, if you have that c squared on the left and it is greater than the sum of the other squares of the other two sides, okay, that greater than symbol tells you it's obtuse, and I always think of obtuse angles as being greater than 90 degrees. So that helps me to remember which way the inequality symbol should be facing. So let's take a look at how we can actually figure this out, okay? So we need to make sure when we set up our equation that we know which side is C. Well, if you think back, C is always the longest side. So the first thing I'm going to do is I'm going to pick out my longest side, and that's going to go on the left-hand side. Okay, and I don't know if it's greater than, less than, or acute. So I'm just going to put a blank box in there, and then I'm going to square my other sides. Okay, 14 squared is 196. I'm going to keep that box there for just a second. Go ahead and use your calculator on this quite a bit. On a test or something, this is the line I want to make sure you have, and then, you know, you don't have to show 100 plus 121. But if we add 100 plus 121, we get 221. And 196 is less than 221. Less than means it's an angle less than 90 degrees, which would be an acute triangle. Okay, so that's kind of how that works. We have that blank box in there so we can kind of work with it just a little bit. 6, 8, and 10. Longest side, that's going to go on the left side. So I'm going to have 10 squared. I don't know what symbol is going to go in there, greater than, less than, or equal to. And then I've got 6 squared plus 8 squared. And I end up at 100. Well, let's see what's going to go in the box here. 6 squared plus 8 squared is 100. Those are equal to each other, which means if they are equal, that means it is a right triangle. Okay, let's just look at a couple more in here real quick. 12, 16, 20. Longest side. So I'm going to go 20 squared. Don't know what's in the box. 12 squared plus 16 squared. 20 squared is 400. In the box, 12 squared plus 16 squared is 400. That's equal again, which means equal tells me that it's a right triangle. I'm going a little bit fast with my writing and things like that. Feel free to pause the video at any time and you can get caught up with me. Some of these I'm kind of going a little quickly through them. So I'm going to find my longest side. I'm going to have 7.8 squared. I don't know what's in the box. I'm going to square and add my other two sides. 7.8 squared. Again, a lot of this is calculator work. So I'm going to have 60.84. And then on the other side, when I square and add them, I get 72.98. Well, 60.84 is less than, okay, an angle less than 90 degrees is acute, so that triangle is going to be an acute triangle. All right, let's look real quick here at the last two. Longest side, I'm going to say 12.2 squared. Don't know what's in the box. 4.1 squared plus 8.2 squared. 12.2 squared is 148.84. Don't know what's in the box. If I add those other two sides together, I get 84.05. 148 is most definitely greater than 90 degrees, which means an angle greater than 90 degrees would make me think of an obtuse triangle. Okay, last one here. Okay, let's take a look at the last one. My longest side, 13. I'm going to say 13 squared. Don't know what's in the box. 5 squared plus 12 squared. 13 squared is 169. Don't know what's in the box. 5 squared plus 12 squared is also 169. Those are equal, which would make this a right triangle. Okay, so as you're doing these, you need to make sure you're squaring all of your numbers. You're not just adding them and comparing them that way. You have to actually square them and then see if the longest side, how that compares to the other two sides. So there is a class kick for you to work on. Good luck.